also because last year I was so into the endurance sporting. Okay, the swimming. During the fasting month, I train for the swimathon. It's like open water swimming from the island, come back to the land. Uh, but it's like 6.5 kilometer, but we have to complete within 4 hours or 6 hours. I can't remember. Last year I did that. Okay, so during fasting month, Ramadan, I break my fast, pray, and after that start training from 8:30 until 10:30. Then drove home with my husband. Of course, I did everything with my husband. Drove home from the swimming pool to my house around like 50 kilometers. I picked up my kids and all that. Then we left around 12:30 midnight. Then tomorrow we did the same. Fasting, swimming, fasting, swimming, fasting, swimming. It was like, I don't know what to say because I'm fasting, right? If I'm not fasting, it should be still okay because the swimming was done right after the Ramadan, the fasting month. So we train really hard, but I swam the distance is actually 6.5 kilometers. But the actual day, because of the current sea wave, it drifted us apart from the sea. And I swim around 8.9 kilometers, and my husband swim 9.5. I cannot finish it because the sea current too strong. And I see the land. It's very near, only 500 meters. I can swim, but I cannot reach the land because the sea push you away, no matter how strong. And at that time, I already have like sea sickness. I forgot to take the sea sickness pill medication before I start swimming. So I vomit and all that. I cannot. Then my husband continued. He finished strong at 9.5 kilometers, reached the land. So it was like last year. But this year, I slowed down. I don't want to do the endurance sport anymore. I'm more into like Pilates, reformer Pilates, mat Pilates, and yoga. But I did a bit of cardio, yeah, because I was a marathon, so I was a marathoner, so I still do cardio because I don't want to lose that strength, right? So cardio is like you have to do it almost every day. If not, during the fasting month, all your stamina gone, then you have like another month to collect all the energy. Okay, yeah, to gain back the strength. Okay, so now your study time. During my study time, I didn't do the physical thing, so you don't have to do now. After when you finish study, when you get like your work life balance bit so a bit sorted, then you can do it. Okay, during my time, this time I didn't do the physical, but I do only a bit only when I'm free. Okay, okay, let's do last question of 3.1. Okay, so actually this is like a schedule equation. Okay, so you see here, it's quite easy actually to do. Okay, but maybe the thing that you cannot do is this line, right? This line and this line. Actually, this one is, okay, you create a limit space from 5 to negative 5 for x, and also for y is 5 to negative 5. Okay, then you put the equation z is equal to x squared minus y squared. Okay, uh, then you use the equation to plot it. Okay, okay, so yeah, I please do mesh grid. Okay, please do mesh grid. Okay, I will put in tips. I put in pins. Okay, so you create x and y in mesh grid from negative 5 to 5. Z is equal to x squared minus y squared. Then you use sub. Okay, then you use sub. Why? And comment. Okay, so if you just run this, you will get a saddle like this. Okay, you get a saddle point like this. Okay, now your task is you have to do a line yellow color in the middle of here and also in the middle here, then put a marker in at the center of the saddle point. Okay, and put the marker of the saddle point. Again, you have to use hold on. Okay, you have to use hold on. So you create another variable which is from -5 to 5 for y, sorry, for x, and for y, I put 0. Okay, why I put 0? Because if you see here, okay, if you see here, okay, this one is, okay, when y is equal to 0. And this one is when x is equal to 0. Okay, this one is when y is equal to 0. Okay, this one is when x is equal to 0. Okay, so you have to think a bit. Okay, so this one, okay, you put that x squared minus y squared, then you put whole on. Okay, you will create a line. It's okay. I have to do everything. Okay, and plot. I use plot 3, x, x, y, y, z, z, and I use yellow, and line width I use 3. So you see here, when y is equal to 0, okay, so this is the yellow line. Okay, after that, we have to make it when x is equal to 0, to make it like here, the vertical. It's not vertical, the horizontal here, the line horizontal here. Okay, so this one is when x is equal to 0. This one is when y equal to 0. So you see here, this one all y is equal to 0. So we create another y. The value is between -5 to 5. Okay, then we plot it. Here. Okay, so this one is when x is equal to 0, and the other line here is y is equal to 0. Okay, so now we have to plot the marker in the center. Okay, if you don't know, you just put your cursor here, then you see this one, x0, y0, z also 0. So you do plot 0, 0, 0 for x, y, and z. Okay, red circle, marker size is 10, marker face color is red. Okay, so you see here, you get it, the red color. Okay, it's exactly the same like this, right? Same like, okay, exactly the same, like how in MATLAB. Okay, so you get it. Okay, so this is how you do a saddle point in MATLAB. Okay, this is how you do a saddle point in MATLAB. Okay, any question? Any question? Yes, if you don't know, please study line by line. Okay, I use everything in LaTeX because it looks nice. Okay, so let's look at 3.2. We done 3.1. Okay, let's do 3.2. Okay, this one is graph of multivariable function. Okay, previously we do 3D, but plane in 3D. But here we will use level curve, planes in 3 spaces, quadrics, and also level surfaces. Okay, so if you still remember, we used ISO value previously. Okay, here we're going to use ISO value. Okay, level curve. Another option for visualizing function of 2 variables is to use level curve for a system of dimensional as such because they are points x, y, and xy on which the value of xy is constant. Okay, we have done this before. Okay, but for example, in the weather chart, level curve representing the same temperature point, we call it as isotherm, and contour line of equal pressure isobar. Contour line represent height, okay, that are equivalent that can describe the surface in space. Okay, usually this one we use a lot in geographical and also geographical meteorology because we want to know the ISO level, the ISO bars, the pressure, and also the contour line. Okay, let's say we want to plot the height of a mountain or the water level inside the ground. So we use the level curve function. Okay, so for level curve, drawing different contours corresponding to constant height can be described as a map of line on the surface level. Okay, we call it as contour graph. Okay, after this, we are going to use contour function. Okay, the contour graph can be represented in 2 and 3 dimensions. Okay, same like previous one, we can use 3 and 3 dimensions. So we use the region of the surface, Earth surface. Contour line represent the height above the sea level, called it as topographic map. This map shows the variance with respect to x and y. Okay, when the space between the contour line is large, it means that the variation of the variable is low, while a small space indicates a rapid change of x. Okay, so for contour, we have several functions to use. Contour Z, it draws the outline for the Z matrix graph. The number of contour lines to be used are chosen automatically. This one means, okay, you let the MATLAB to choose your contour line. Okay, but if you have control Z and it draws the graph outline for the Z matrix using n contour line. So which means that, okay, they will use it according to the color that you decide, the color of contour line. Okay, if you have two values, x, y, z, and n, okay, draws the graph outline, okay, for the Z matrix in the x and y using scaling defined by the vectors x and y. And if you want to use 3D, we use contour 3Z, contour 3ZN, or contour 3XYZN. It's all in three-dimensional. Okay, P color is draws the graph outline, okay, to the matrix SYZ using a representation based on densities of colors. So we call it as this density chart. Okay, I'm going to give you a contour plot coding. Okay, please see your tips now. Okay, so this one, okay, I'm going to use again. Okay, this one is I use I comment all the above. Okay, please look at the first paragraph. Okay, I do a mesh grid from -2 until 0.1. Sorry, until 2. The increment is 0.1. Okay, I sin x times sin y. Okay, and this one I use subplot. Okay, please comment this first because I want to see the 3D graph of this. Okay, so this is the 3D graph of this. Okay, we have learned in 3.1. Okay, we have learned 3.1. Okay, now I'm going to use the contour value. Okay, the contour value. Okay, please comment sir. Okay, don't do the subplot first. Okay, later on we do. Okay, then uncomment contour. Okay, uncomment contour 3. So this one I use XY value matrix and also Z value, which is sin X times sin Y. Okay, here I use 20. Okay, and line width is 3. Okay, so this is the contour plot. So which means that it doesn't color the surface, but it only draw the line. Okay, it only draw the line. Okay, this is 20. So let's say I want to change. Okay, let's say I want to change maybe 10. Okay, let's say I want to change 10. So the color, sorry, it will have like this. Okay, it will have like this. 20 is nice. If I change 30, okay, it will become more closer. The line becomes closer. Okay, but here maybe 20 is just not. Okay, because my line width is quite thick, which is 3. Okay, now, I'm going to do, please comment this, contour, comment this, and use this. H is equal to contour X, Y, Z, and then we put a C. You see here, yes, you see here, okay, when I use a GCA, okay, H is equal to GCA that we did before, okay, when we do contour here, so you see here, we have a contour label, which is H. Contour label H, which is the width here is 10. Okay, no, the width is not necessarily. The distance, okay, is around like, it's stated as it's 10. So we put a label according to it. Okay, we put a label according to it. Let's say I want to change until 20. I want to change until 20. You see, it becomes more narrow. Okay, it becomes narrow. Okay, so I think 10 should be nice for this plot. Okay, only a few levels here. Okay, so this is you when you want a contour the level. Okay, if you want a contour with the to demonstrate by using P color. Okay, so comment H and comment T level. Okay, we are going to use P color X, Y, and Z. Okay, so if you see here, if it is P color, it is a contour, but it's in a grid line. Okay, it's in a grid line, but this one doesn't have color bar, so you don't know the value, but maybe you can put a color bar here. Okay, so okay, this is a P color, but I put color bar here so that we know the like exactly what is the value between the value. This is the contour plot. Okay, now I'm going to demonstrate to you. I use subplot to differentiate between the three types of contour plot. Okay, please comment color bar only and uncomment the rest of the thing. Okay, so you see here, I have 4 types of graph. This one I use surf. This one I use contour. This one I use this, which is the contour label. And this is I use P color. You get it? Okay, please form a group of 5, okay? Okay. Then after the class, I will do the Excel spreadsheet and see how? Okay, so this is the contour plot. Okay, now, okay, next is we want to use plane in three space. Okay, a flat plane can be plotted by either an equation of the place or one of the coordinates is constant. Okay, we have done it in practice 3.1, question 2, right? Okay, so which is we have three space, x, y, and z. Okay, so and quadratic surface are the graph of quadratic equation in three Cartesian variable in space. Like the graph of quadratics in the plane, their shape depend on the signs of the various coefficients in their quadratic equation. Okay, now I'm going to share to you the themes. Okay, the themes coding, in themes, the coding for plane. Okay, okay, here I use the plane. Okay, I use the plane and okay, so I create the matrix, square matrix, okay, from -1 to 1. Z I put as 0 and Z2 is x plus y. Okay, now I'm going to use the, okay, to color them in red, okay, to color in red, okay, for the first place. Okay, see here, this is what we did before, right? Okay, this is what we did before, right? But this one I want to color for this one is when Z is equal to 0. Now, if when Z is equal to X plus Y, okay, then I use for on, but I use green color, okay, I use green color, okay, I add another one, okay, which is this, okay, so I color this one in the red and X plus Y, so another one is here. So if you rotate it, okay, it's actually like, look like this, okay, if you rotate it, okay. If you rotate it, it actually looks like this. This one is when Z is equal to 0. Yeah, the green one is when Z is equal to X plus 1. Okay. For quadrate, I forgot. Okay. Next is, okay, sphere and ellipsoid. Okay. A sphere is the graph. Okay. I know that we have do it if we have did it in chapter 1. Okay. But this one is maybe you will understand it more. Okay. A sphere is the graph of an equation number of the form is equal to r square for some real number r. Okay, radius of the sphere we call it as r. Okay, so please remember this is the equation of a sphere. So you have to create, okay, the mesh list of x and x, y, and z. Okay, ellipsoid is the graph of equation. Okay, ax squared plus by squared plus cz squared equal to r squared, where a, b, and c are all positive. Okay, a sphere is a very special ellipsoid where a, b, and c are equal. Okay, so you see here, all a, b, and c is equal to 1 here, right? Okay, so this is sphere because sphere is like a ball. It means like it's round and it has equal sides. Okay, but ellipsoid is maybe can be oval or maybe can be something else. Okay, so they have a built-in function of MATLAB that we can use to plot them. Okay, so we're going to look at sphere. Okay, I want you to try to run it. Okay, so this is the sphere. Okay, this is the built-in function of sphere. Okay, we use the x, y, and z. I put the sphere 50. Okay, I put the sphere 50. Okay. Okay, so here I will get it like this. Okay, now, I will solve it next here. Okay, and next is, okay, I want to use, okay, here 3x, 3x plus 5, 3y minus 5, 3z plus 5. Okay, this one is actually, okay, get it like this. Okay, so you see here, this one is 252 is the ellipsoid. I think I will put it here. Sorry. And A, B, and C is the same, okay, you will get a speed. Okay, if you A and B is different, okay, so okay, here you see three. This one is ellipse. Okay, okay, please comment this. And uncomment this. Okay, you put this column map. So this one is, okay, your sphere is centered at 3, -2, and 0. Okay, you see here, +3, -2y, and as that we put as 0. So it'll be like this. Okay, what if we want to do 0, 1, -3? Then you comment this, then you put it here. You see that? This one is center at 0, 1, negative 3. 0, 1, and okay. Okay, it will be 0, 1, negative 3. Only use okay, and let's say we try another one. Okay, so this one is when it is at, okay, with, it is a sphere, okay, but center is 4, negative 3, and negative 5. Okay, 4, negative 3, and negative 5. Okay, this one is all the blue, this one, the color is all used spring color. Okay, it's all used spring color. Okay. Okay, now uncomment everything. Okay, please comment everything. Uncomment the bottom paragraph. Okay, then run section. Okay, here you see we have a hemisphere that we cut out into two. Okay, that we cut out into two. Okay, so on X, Y, Z, okay, X, Y, Z on the left side. Okay, and UX, UY, UZ is on the right side. Okay, do you get it? This one? Yeah? Okay. So this is quite easy compared to the chapter 1. Okay, compared to the chapter 1 that you learn to draw it manually. Okay, this one is like a shorter way. Okay. Okay, I'm going to give you ellipsoid coding. Okay, this one I share in this. Okay, so that's ellipsoid coding and try to run this. Okay, this one I use subplot. Okay, because I want to see next side by side. Okay, this also you use color map string. Okay, and okay, x, y, z is equal to, this is the function built in MATLAB ellipsoid 0, 0, 0, 6, 3, 2, 30. Okay, so actually that means that, so it's x, y, z, and followed by radius, 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 and n is actually like the color x, x, y, z. Okay, because we want the mesh wire, okay, to be visible in our sphere. Okay, and the next part is actually the we use SERP. Okay, we use SERP a plot to plot our ellipsoid. Okay, so this is the sphere, the difference between the if you use ellipsoid and also SERP. So actually, MATLAB has many alternative functions to use. Okay, you exactly do the same. Okay, it's exactly serving the purpose. It's the same thing. Okay, but on right side we use SERP, so it color the surface. But actually, we can also make similar using the ellipsoid function by using the mesh function and put it in cell. Okay, and we don't have to color the surface, then we get similar like how you do in on the right on the left side. Okay, so this is ellipsoid. Okay, so like I said, ellipsoid. Okay, A, B, and C has a different number, but here it is equal. Okay, next is we're done with sphere and ellipsoid. Okay, we are going to do paraboloid. Okay, what is paraboloid? Okay, paraboloid is surface whose intersection with plane perpendicular to any of the coordinate axes are parabolas in those planes are called paraboloid. Okay, so this is a very basic thing, I think. Okay, so is z is equal to x square y square. So it's in the intersection. Okay, before this you do plane, right? Okay, so paraboloid means okay, parabola intersect with plane. Okay, is perpendicular to the x and y, okay, and are still parabola, but the two set of parabola differ in the direction in which they point. Okay, so we see that we call it as if it is differ, okay, we call it as the surface as hyperbolic paraboloid, okay, and sometimes we call it as saddle surface. Okay, you have done in 3.1. Okay, so in paraboloid, okay, I show you the shape of the paraboloid that has this, okay, the saddle surface is x square minus y square, okay, plane perpendicular to the x and y axis, okay, but the two set of parabola is different direction, so that's why the saddle is like this, okay. Okay, now we want to do when x square plus y square, okay, I share this code in Teams. Okay, we do paraboloid, normal paraboloid first, okay, not the paraboloid bounded. Okay, so we create a matrix from negative 5 to 5. Increment is 4. Okay, so this one, the first one is x squared plus y squared. And that limit is only 0, 25. Okay, then next paraboloid is x squared over 4, y squared over 16. And the last one is x squared minus y squared, which is the saddle equation. So you see here, this is a paraboloid. This one saddle we have done before, and this is paraboloid. Okay, and this one is, what is it? Elliptic paraboloid. Okay, and this one is hyperbolic paraboloid. Okay, paraboloid, elliptic paraboloid, this one is hyperbolic paraboloid. Okay, next is I want to do a paraboloid bounded. Okay, I share with you in the second code, paraboloid bounded. Okay, so maybe this one you can try first. I create mesh grid of -2 until 2 for x and y. Z is equal to x squared plus y squared. And I put a face color, okay, blue, H color. Limit is 0, 4. Then I do another one in ellipse, using the ellipsoid function, 0, 0, 4. Okay, and the center, sorry, the radius, sorry, the center is 2, 2, 0. Okay, so here, if you do it, you will get like this. Or parabolic bounded. Okay, so which means that, okay, okay, I think I do one by one. Okay, so the first one, I'm going to do a paraboloid only. Okay, so this is the paraboloid. Okay, so why it has the red and blue color? Because I put the face color is blue and the mesh color, the edge color is red. So it will be like this. Okay, so let's say I change it. I don't do it. Maybe I make it yellow. Okay, so you say it will change to yellow. Okay, so now here it is not bounded, right? It is like this, like a basket, like a basket, like this. Okay, this one x squared plus y squared. Okay, it's like normal paraboloid. Make it bounded. So which means that if it is bounded, which means that I want to fill up. Okay, like I pour water inside the basket. So I want to see it fill up, cover everything here. Like I want to put a liquid, I want to make it cover here. Okay, so I use ellipsoid. Okay, I use ellipsoid. Okay, so for ellipsoid, okay, I use XCYCZT is ellipsoid 004. Okay, 004. Okay, and the radius is 220 and it's 100. Okay, so when we do it, there's no line style and the face color is blue and I put the face alpha is equal to 0.9. Maybe you can change it lower a bit, 0.7, so you can see the difference. Okay, so this is a bounded. So we cover everything, okay, so that it will look bounded. Okay, because paraboloid, okay, it is bounded. Here, you have to side here, we use ellipsoid to make it fill inside the tank. I go a bit faster because I want to focus on the practice question. Next class, I will focus on chapter 6 because we're going to use it for the assignment. And I have to finish chapter 3 by now so that you can do your quiz 2 by this Thursday. Okay, I know I will get complaint that very fast, too much. I know it because it's short semester. We only have 5 weeks. So 15 weeks of learning we compress into 5 weeks. Okay, so that's why it's a lot, it's fast, and very demanding. Okay, we also as a lecturer have to keep, mark very fast and return to your work, okay, on time. Okay, so, and also prepare everything for you. And I will return your quiz once the grader finish marking it. Okay, for quiz 2, I will mark it. For quiz 1, someone else will mark on my behalf. Okay, next is hyperboloid. Hyperboloid surface in 3D space. Okay, I know it is to hyperbola in the plane. Okay, their defining characteristic is that their intersection with plane perpendicular to any two of the coordinate axes are hyperbola. Okay, so hyperbola example equation is x square plus y square minus z square equal to 1. Okay, we call it as hyperboloid of one sheet. At the right, illustrate this shape is very similar to the one commonly used of nuclear power plant cooling towers. Okay, so it's shaped like hyperboloid. Okay, so for hyperboloid, another two, when it has two sheets, okay, is x square plus y square minus z square is equal to -1. Okay, I'm going to share the hyperboloid equation. Okay, it's okay. I will share you the, yeah, it's okay. I put in things. Okay, we are going to do hyperboloid of one sheet first, then do hyperboloid for two sheets after this. If we do hyperboloid of one sheet, we do metric from -4 to 4. Okay, RC is we do a matrix that follows size x. Okay, and after that we do here xm and x square plus y square minus 1. If it's greater than 0, z is equal to square root of x square plus y square minus 1. Okay, so we do the looping here. Okay, for x and also z, because x and z has, okay, then we use sub. Okay, okay, so please comment sub x, y, negative z first. Okay, we only plot x, y, and z. See, okay, you see here, this is the hyperboloid of one sheet. Okay, hyperboloid of one sheet. Okay, x, y, negative z, we plot it. So you see here, it is, okay, it's perpendicular to each other. Okay, it's actually an image of the upper part. Okay, to be honest, I never use hyperboloid in my life, only for the MATLAB. Okay, I don't have any, I'm statistician, I don't have any, what do you call it, any situation that requires me to plot a hyperboloid graph. Mine is only normal graph and normal model, and model, not graph. Okay, so this is hyperboloid of one sheet. Okay, now I'm going to do hyperboloid of two sheets. Okay, please comment on the upper part, then run on the second part. So hyperboloid on two sheets. Okay, so do hyperboloid of two sheets. So the same -4, 0.21. Okay, so the equation is z square, x square plus y square plus 1. Then after that, we plot x2, y2, z2. Then we do another opposite direction. So this is hyperboloid in two sheets. So you see it is floating. Okay, so my student asked me why we do a loop for this and this one. Like the normal circle graph that we use by using the equation x squared plus y squared plus 1. But for one sheet here, okay, we have whether it is greater than 0 or not. If it's greater than 0, then you have to do certain equation here, which is -1. Okay, as square root of x squared plus y squared minus 1. But if it is greater than 0, it is x squared plus y squared minus 1. Okay, we don't have to square root. So we have a certain condition for hyperbolic one sheet. But for hyperbolic sheet, we don't have any, and it's already built in function in MATLAB. Do you get the plot like this? Yeah? Okay, great. Okay, now is the level surface. Okay, level surface with gradient vector like this, like this. Okay, so when f is a function of three variables, the level set usually consists of one or more two-dimensional surface called level surface. So if we can graph level surface, level set of a function, we can get important information about its properties. Level surface of this function can all be graphed by solving for z, then use the usual command for graphing function z is equal to gxy. Okay, so let's see how to do programming in level surface. Okay, I show to you level surface without the gradient first, and next code is level surface with the gradient. Okay, so this is the matrix that I create negative 2 to 2. Okay, my level surface is x squared, y squared minus x squared plus 4. Okay, then we do sub. Okay, comment that is first. I want to show to you. Okay, so this is the level surface for this. Therefore, x squared plus y squared minus x squared plus 4 settle, but our our constant z is equal to, and our w constant is equal to 4. Okay, now let's see if we put negative 4. So you see, I create another one, okay, 8 at the bottom, okay, at the bottom, which is negative 4. Let's say negative 8, so which means that I create another one on the bottom, okay, so this one is level surface. If we just play around with the value of z at the end of self common. Okay, so this is level surface. Okay, so you see that we create a like surface but different level. Okay, next is level surface with gradient vector. Okay, level surface with gradient vector. Okay, this one is actually a part of the practice question. Okay, a part of practice question. Okay, so here, okay, I do match grid. So I put previously it's x squared minus y squared, right? So this one is 8 minus x squared minus y squared over 4. So 12 minus x squared minus y squared over 4. And Okay, I comment this first. Okay. Then I see that this is the first one is like hyperbolic, but opposite. Okay, now I'm going to create another one. Okay, I'm going to create another one. Okay, but I put it as I want to create on top of it, which is in yellow color. I want to create on top of it. Okay, so you see, I create another one is on top of it. Okay, quiver 3 is actually this one. Maybe I need to put it first. Okay, you create like this. Okay, quiver is actually I just want to show you the arrow. Okay, that show which one is the origin, then which one is the update, the model, not model, but the update. And quiver is actually the okay, so this is level surface with gradient. Yes, this is a level surface with gradient. Okay, my thesis, if you don't know how to code, at least you know you have the code and you know what it means. Okay, I'm not going to ask you to memorize the code, but at least you know which code will, what code we get inside, which code we got level surface, which code that we get hyperbolic, and which code we get inside. Okay, I know it is like beyond of human being capabilities to maybe they have, okay, but for me, like I still need reference to do the coding. Okay, I'm not going to ask you to memorize it, but at least you know what it is represent. Okay, any question before I begin with the practice question? I have quite a lot of this question. One, they use marker. Marker for each point of the sphere, but there's no mesh, there's no each color. One is hemisphere, cubic interpolation, this is a surface. Okay, we try to do whatever we can. Any question? Okay, now it's 10:19. Uh, we begin at 10:25, 5 minutes break, 6 minutes break. Thank you.